Practice cumulative. Yeah, practice cumulative. It's 2021, new year. I haven't had a talk for a bit. So yeah, practice cumulative. If you're watching this, you care about this cumulative, which is kind of like a midterm, but not really quite the midterm because we're not having midterms. But this does cover everything that we've done up to this point in the year. So I just want to make sure that you understand what's going on here. Of course, you're more than welcome to try these problems and then see how I solve them. I think a lot of these are self-checking. So there's that option too, to just check your work as you move through these, but I'll talk through how these work. So we have this table that seems to be going up in increments of 1 for the n term. And that's pretty consecutive, or that's continuously adding 1. Whereas for f of n, well, let's think. If it's jumping from 2 to 6, this would be adding 4, but are we adding 4 down here also? No. So we're not adding 4. So please rule that out. We're not adding 4 over and over. But how could we also go from 2 to 6? Or from 6 to 18? Or 18 to 54? We can't quite add, but we could multiply by 3, which we would consider our common ratio. So we're looking for an option that has a common ratio is 3. And since we're multiplying, remember, we've been saying that real G's multiply their money, meaning we're talking about a geometric sequence. So the only option that makes sense here is this one, geometric sequence with a common ratio of 3. Click that and move on with your life and submit it. Done. For this one, we're given the sequence, we're finding the nth term. So we're trying to make an equation out of this. You have a few ways you could go about this, but personally, I'm going to go back to the 0 term. So the 0 term is before the 18. I know that normally this moves forward and just keeps adding 4. So how could I go back to the 0 term here? Hopefully you're saying by deducting 4. So 18 minus 4 gets you 14. And so if we had to use a sentence to talk about this, we could say, starting at 14, we add 4. And since we're now at the 0 term, we would just say that this is n times. So we're looking for something similar where we have 14 and then we add 4n. Can you spot the option that makes sense? This could also be rewritten to 4n plus 14. So that first option looks the best. Send it. 14th term here, I'm going to start on the n where n equals 1 term. So this is starting at 3. I keep multiplying by 2. And this keeps happening over and over. So I'll make another sentence just to describe what's happening here. So starting at 3, we multiply by 2. N minus 1 times. Again, because we're at the n equals 1 term, so we have to give respect to that. So if I was going for the 14th term, I would start at 3, multiply by 2. My exponent here should now be 14 minus 1, getting me 24,576. There you go. We have this table here, starting with 50, we keep doubling. We're trying to go to the 6th week. You could keep just putting these out if you want, or you could start at 50 and multiply by 2, 6 minus 1 times, which is really 50 times 2 to the 5th power, which is going to be 1600. So notice I had to make the equation to make this thing a reality, or you could have just kept multiplying by 2. that's another option you have, but I don't know. If you want to keep doing that, go for it. But and you see pretty quickly that 1600 is the best option there. We have this auditorium with the 20th seat. So I'm going to put together a table that's going to make this a little bit easier to work with. So I'm going to deal with rows, and then I'm going to deal with the number of seats. So in row 1, I have 6 seats. In row 2, I have these 4, so I have 8. And then that just keeps adding on 2. So notice, just keeps adding 2 over and over. So if I was using in a sentence to talk about this, starting at 6, we add 2 n minus 1 times. Because again, we're dealing with row 1 that only has 6. So if I wanted to find the number of seats in the 20th, I could put together this equation, 20 minus 1. So really, you need to find 6 times 2 to the 19th power. Do you know what that is? Find it real quick. The slight blooper, actually, I did this wrong. I forgot to add 2. So adding 2, and then this would be 20 minus 1 times. So this is really 6 plus 2 times 19. Just be careful there. So that's going to get you 44. If you're not convinced, try it out. But 44 is what you need. Domain, and all of these are multiple choice, and they'll tell you if you're right or wrong. Again, domain is going to deal with X values. So that's a really big deal here. Just X values. How I personally go about this is by making these marks of the leftmost point, which is here. We see that we get the function going all the way up to here with no breaks. So we want this to go from -8 to 7. And we want to use brackets because these are filled in. So the only option that makes sense is this one. And it's correct. What do you know? Domain now talking about the inequality. Well, I'm actually going to rewrite what we had, -8 to 7. And we're looking again for X values. So the option that includes -8 and 7 and also has X in between is this first one here. Range deals with Y values. You know this. So this is Y values. And so when I approach this, I'm thinking, what's the lowest point? And then what's the highest point? And does the function have any gaps in between there? But we see that it doesn't. So we really want this to go from -6 to 5. And we'll use brackets. And that does that. Same thing from -6 to 5, but we're talking about Y values. And this one makes the best choice. Maximum, I think this is pretty easy to spot, but if you're not convinced, it's right here because this is the highest point, and this is when X is 3. The Y coordinate's 5. It's a 3, 5. Type that in and move on. Maximum, highest point. Minimum, how's that any different? What do you think? Hopefully you're saying it's the lowest point, which is right here, which is going to be when X is -3, the outcome is -6. Put that in and send it. Increasing, okay. Well, I think it might be helpful to just pinpoint where this is happening. Don't fall into how it's multiple choice. Really look at where it's increasing. So where do you think that's happening? Hopefully you're saying from here to here and also from here to here. So -8 to -5, that's not it. 5 to 7 is over here where it's just constant. That's not it. -5 to -3 is decreasing. That's not it. -1 to 3. Yeah, that actually is looking good. So that's one we want. 3 to 5 is decreasing. And notice we need 2 intervals. So the other one that's going to make sense is from -3 to -1. So those 2 intervals work just fine. X-intercept, super simple to spot. We know that occurs right here when X is 3, outcome 0. For the Y-intercept, a little bit higher up here in this direction. We see this occurs now here where X is 0, the outcome's 3. Meaning the outcome being the Y coordinate. Quick look at graphing. These again are self-checking. This is in slope-intercept form. You know this because it's mentioned right here. So this is in the form of y equals mx plus b. We've seen this form quite a bit. M is our slope. B is our y-intercept or our starting value. You can think of it like that too. So this is saying starting at -4, because that's our y-intercept. So starting at -4, well, what's our slope? What do you think? Well, you're saying 2/3, where we have our rise of 2 and our run of 3. So we're running 1, 2, 3. We're hopping up 1, 2. Got another point there. And again, you can fall back on the directions that the slope is giving you to do that. And do the same thing again to get other points. Over 3, up 2. Over 3, up 2, what you gonna do? Up 3, 2, what you gonna do? Up 3, 2, what you gonna do? That'll work. There are your 4 points. And I'm actually going to show you how you can check your work. Scoot on over to, which slide is it? Oh, it's not slide 28 now. We switched these things up a little bit. Oh, it's this one. Yeah, that would have gone through the points. Yeah, I'll actually show this one using the other actual graphing tool. So same thing. Slope in this case is -3/4. And I just put the negative sign with one of the terms, not both, because one of the negative sign's telling us it needs to go down and to the right. Doesn't matter which one you use, truthfully, whether it's the rise being negative or the run being negative. All right, so when we start at 2, we're running 4, and then we're going down 3. All right, and so I'm actually just going to map out the line that way. Hopefully that's okay with you. We see we get this other point that's right here. Yeah, this one right here, this one right here. Again, over 4, up 3. Get us back to that. Over 4, up 3. All right, so this one, let's check our work. Because honestly, the other ones in this are just the same kind of thing. We see that it's the blue line and we have these blue dots. There you go. That's slope-intercept form for you. Point slope form, a little bit different, where we still have our slope, which in this case is 2/3. We have x minus 4, where this is our x1 coordinate, and then +1, where this is our y1 coordinate. So one point that's on the line, and this is super important, is just 4, 1. and our slope is still 2/3. So we can plot 4, 1. That's just 4 in the x direction, 1 in the y direction. Plot that. We can then use the slope, go over 3, 1, 2, 3, up 2. That's good. We can keep plotting these. Same kind of pattern again, go over 3, up 2, over 3, up 2. Pretty fun. Map that line, have it go through all of them, call it a day, and check your work because you can do that. Look, there it is. It's right there. Done. Relationship with Sally and the donut shop. Gives out 3 free donuts on the first day. Plans to give out an additional 3 donuts more each day. So as a quick table, I'll have day. I'll have donuts. On day 1, we give out 3. On day 2, we give out an additional 3 more. So that would be adding 3 to get 6. Keep doing that. Add 3, get 9. This is definitely linear because we just keep adding 3 every time. So we keep 3 donuts the previous amount. Done. This has a percentage in it, starting with 11,000, earning 4.3% in interest from the bank. This is exponential. Madonna's cookies popular. Madonna's cookie bakery is so popular. She started by baking 9 cookies on day 1. All right, might be good to draw a table here. So we'll have the day, we'll have the cookies. Day 1, 9 cookies. We then triple the amount moving forward, so times 3. And this just keeps multiplying by 3. So eventually, think of this. We're starting at 9. Starting at 9. We multiply by 3 and minus 1 times. Again, because this is a day 1 problem. So 9 multiplied by 3, put in an exponent with parentheses and minus 1 times. That should do it. Pedro with the push-ups. Originally, this was Scott's workout plan. I think that was the name of this one. What's going on here? Doing 3 push-ups on the first day. So on day 1, we have 3, adding 5 additional push-ups each day. So we just keep adding 5. Could keep going with this if you want. But eventually, again, we're trying to make the explicit equation. So in words, what's happening here? We're starting at 3. Add 5 and minus 1 times. Or I suppose if you want to go back to the 0 term, you could say starting at -2, because if we deduct 5 from 3, that gets us -2. We add 5 n times. So you have the option to have 3 plus 5 n minus 1, or -2 plus 5 n times. Both of those equations work. That should do it. If you have any questions, holler. Thanks for watching.